Here's yet another algebraic identity, and once again, it can look random and useless if we don't understand the relationship that it describes. If you've seen something like this before, you might recognize that you can use a process called the FOIL method on it to multiply the first, outer, inner, and last values. But if you don't understand what this process is doing, you're just blindly following a recipe. If you don't see how it works, you might as well follow a wiffle rule to multiply whatever I feel like. Let's break down what the first half of the identity is describing. We have two quantities we can call A and B, which we can again describe as lengths of line segments. These values are being added together, and the result is then multiplied by itself, which we could describe with an exponent of 2, making A plus B squared. We could describe this by taking the length of A plus B and making an actual square out of it. The area of the square is A plus B times A plus B, or A plus B squared. The values of A and B can change, but they would always create a square. Instead of looking at our shape as one big square, we can break it up into pieces. The A and B lengths make 4 sections, 2 squares and 2 rectangles. One square measures A by A with an area of A squared. The other square measures B by B with an area of B squared. The 2 rectangles share the same dimensions with A on one side and B on the other, giving us 2 rectangles with an area of A times B. Altogether, we could describe a square with an area of A plus B squared as also having an area of A squared plus B squared plus 2AB. This identity gives us a mental exercise in working with something that's a single complex chunk and logically pulling it apart into pieces that are easier to deal with.